Hi there, everybody. This is review number 10, polynomials and factoring. Go ahead and try the SAT problem and we'll have you guys check it in class together. Looking at what's a polynomial, just a reminder the variable has to have a whole number. So if you have x to the negative third, it is not a polynomial. Whole numbers start at 0, 1, 2, 3, 4, 5. No fractions, no decimals. Looking at a polynomial, here's a polynomial. You have terms connected with add and subtract signs. The leading coefficient is the -6, which goes with the degree. Degree is the largest sum of exponents in a term. Here the degree is 3 because it's the largest exponent. 5 happens to be a coefficient along with -6. -6 is just a special coefficient called the leading coefficient, and -3 is the constant term. So just reviewing what degree is again, if you had something like 2x squared yz cubed, you would take the 2 and y to the first power and z to the third power, you would add it together for the degree. So the degree is 6. Polynomial, this is just the formal definition of polynomials. In example 3a, all I did was use the distributive property, first times first, outside times outside, inside times inside, and last times last. Looking at example 3b, if you have not multiplied this way with a box, I would really like you to try this on your notes the new way. This is an amazing way. Most of my students on tests who use this method end up getting the problem right. So please try this. What you do is you take the first polynomial and you write it across the top, making sure the sign in front goes with the term behind, like -3x and -6. And then you write the second polynomial along the side. Now all you do is it's like the area of a box. It's length times width. So 2x squared times x squared gives me 2x to the fourth. So you write 2x to the fourth in that box. 2x squared times -3x is -6x cubed. And 2x squared times -6 is -12x squared. I recommend you stop the video and try to fill in the rest of the boxes. All right, -4x times x squared is -4x cubed. -4x times -3x is 12x squared. -4x times -6 is 24x. And then this last box, you take the 1 and multiply it to the x squared. You get x squared. 1 times -3x is -3x, and 1 times -6 is -6. What you're going to do from there is you're just going to combine like terms. A lot of times the diagonals are what we'll add together, which is super cool. So you have the 2x to the fourth. You have the -4x cubed and the -6x cubed, which is -10x cubed. You have the x squared, the 12x squared, and the -12x squared. So the 12x squared and the -12x squared cancel, leaving you just the x squared. You have a -3x and a 24x, which is going to give you a positive 21x, and then subtract 6. So this is a really great method. Instead of distributing and distributing and distributing and then combine like terms, just set up a box. It works really great. 4 is a product of sum and differences. I just want you to remember the word that goes with this. Remember, it's called a conjugate, a minus b and ax minus b, ax plus b. So basically it's just first times first. So a times a is a squared and x times x is x squared. So now you have a squared x squared. Outside insides are always going to cancel on conjugates. So I can write it down, but I usually don't. I know that negative AXB and positive AXB are going to cancel each other out. And then you have last times last, a negative B times B is going to give you that positive B squared. So looking at example 4, if you want to try these on your own and then check with the video. The answers for example 4, if you had problems, I'm going to go over B and C right now. Otherwise, you can just move on to the next part of the video. So looking at B, first times first, x times x is x squared. outside insides cancel. A negative root 3 times a positive root 3 gives you just what's underneath the radical, the radicand, which is negative 3. Looking at C, just as a reminder, when you do first times first, we have rational exponents. So you add the exponents together. So what's 1/3 plus 1/3? 2/3. Some of us miss that. Outside insides cancel. When you multiply last times last, a negative times a negative is going to stay negative. And then what is a half plus a half? It's a whole, and that's where you get y. Looking at the square and sum of differences, be careful. If you have ax plus b quantity squared, you actually have 2 of those. So a lot of kids will just square the first term and just square the last term, and they forget the outside and the inside. So be careful. It's going to be first times first. So ax times ax is a squared x squared. 1axb plus 1axb is 2axb. And that's the term a lot of students forget. So I did outsides, 1axb, 1axb, 2axb when you add them together. You always add outside insides together. And then last times last, b times b is b squared. So there's your answer to that one. All right, looking at this one, same thing. Ax times ax is a squared x squared. And then outsides is a negative axb, and a negative axb is a negative 2axb. Last times last, negative b times negative b is plus b squared. Now looking at the cube, ax plus b cubed. Some of you, if you've learned Pascal's triangle, you could solve this one using Pascal's triangle. I'm just going to have you multiply it out right now. So we already know what the ax plus b times the ax plus b is. It's this right here. I'm going to stop the video and set up boxes. I want you to do the same. Ax plus b times ax plus b gave me this top part, and then I'm multiplying again by ax plus b. Using boxes, this is all multiplication, so ax times a squared x squared is going to give me a cubed. Remember, you're multiplying, x cubed. Ax times this is going to give me 2. You have a squared, and then you have x squared, and then you still have the b. Ax times b squared is axb squared. The bottom, b times this is going to give me a squared x squared b. B times this gives me 2axb squared, and b times b squared is b cubed. I hope you went and tried that on your own. All right, so now what we do is we add like terms from the boxes. I only have one a cubed x cubed, so that's going to be by itself. The 2ax, a squareds, x's are squareds, and the b's are the same. So you have 2 of those plus 1 of those is 3 of those, because now we're adding. So 3a squared, x squared, b. Here, these are like terms. So 2 plus 1 of those is 3 of those. So that gives me 3axb squared. And then you still have the b cubed for your final answer. I'm going to ask how you liked trying the box method versus just distributing. Looking at example 6a, I started by factoring out the GCF of 3x. Then I tried to factor using the AC method, but you can see there was nothing I could find to multiply to get 18, but add to get -4. So therefore, I was done with the problem. On B, I factored out the GCF of 4WY, and I was left with 2W subtract 1. So example 7 is a difference of 2 squares. Just as a reminder for the formula shows that a squared subtract b squared is equal to a plus b, a minus b. So we're going to have numbers that are perfect squares connected by a subtraction sign. So looking at this, x squared is a perfect square, x times x, and 196 is a perfect square, 14 times 14. So therefore, it's connected with subtraction. A plus B, A minus B. A is the x, B is the 14. So you get x plus 14, x minus 14. Looking at B, 3 times 3 is 9. X squared times x squared is x to the 4th. And 11 times 11 is 121. I have A plus B, A minus B. Looking at C, it's a sum. So it's going to be imaginary. If you wanted to factor this, you could. X times x is x squared. And this is going to be the square root of 5 times the square root of 5 is 5. Because it's an add, you're going to get x plus root 5i and x minus root 5i for the difference. I guess it's not difference, for the sum of squares. Looking at D, 5 times 5 is 25, and x times x is x squared, and you have x minus 1 twice. So your B part is going to be just x minus 1. So here's your A and here's your B. You can write it as a difference of squares. So you have 5x subtract x subtract 1, or if you want, I have the plus first, so we can do plus. And then 5x subtract the x subtract 1. We can go ahead and simplify that. This should have another parenthesis. So you have 5x plus x is 6x. Subtract 1. And 5x, you need to distribute that negative. 5x subtract x is 4x. And 5x, a negative and a negative, is a positive 1. So this would be 4x plus 1. And there you go. So the sum and difference of two cubes is the same thing that we did last week, where we did the SOAP. So if you have a cubed plus b cubed, if this is a plus, this will be also a plus. So here's your same. And then the next sign is opposite this one. So if this is plus, this is opposite negative. And the last sign is always positive. So you need to memorize these sum and difference of cubes formulas. Here's the sum of cube and here's the difference of cube. So how do you know if you have a sum of cubes? So the first variable is a perfect cube. And the second variable is also second number is also a perfect cube, 5 times 5 times 5. So now here's your A and here's your B, and you just throw it into the formula. So it's super easy. I think I'm going to try purple. So we're going to have x plus 5, and then we have a squared. So x times x is x squared. And then we have subtract ab. Here's the A, here's the B. So 5 times x is 5x. And then we have plus b squared. And the b is 5, so 5 times 5 is 25. Now, by the way, this part is always going to end up imaginary. So it will never factor in a sum or difference of cubes. Let's look at the next one. We have 3 times 3 times 3 is 27. Let's try my red pen again. So 3 times 3 times 3 is 27. X squared times x squared times x squared is x to the 6th, because you do 2 plus 2 plus 2 for your exponents. And then 1 times 1 times 1 is 1. So I have perfect cubes. So how does the difference of perfect cubes work? A minus b. So the A is 3x squared and the b is 1. So A subtract b. Notice the b is positive 1, and then it's always subtract here. And then you've got a squared. Be careful, students miss this a lot. You have to do 3 times 3 is 9, and then x squared times x squared is 2 plus 2, which is x to the 4th. Then you have plus a times b, 3x squared times 1 is 3x squared, and this is a plus, SOAP. And then b squared is 1 times 1, which will give you plus 1. Again, this part will always be imaginary. And there you go. I just factored a sum and difference of cubes. Example 9 is how to group when there's 1, 2, 3, 4 terms. So you split it down the middle, and you have an x cubed and an x squared. So the GCF is x squared. You factor the x squared out and you're left with x subtract 3. And then here's a plus sign. So you always include the plus in the middle. You have a 3 and a 9, so that means a 3 will factor out and you're left with x subtract 3. The cool thing about these problems is when these are the same, then you can factor out that binomial and it's an x subtract 3. So the x subtract 3 is going to factor out of this problem. It's like you have two parts with the plus sign in the middle, and now you're left with the x squared plus 3. And you're done. That's your answer. Looking at this one, we have an x squared that will factor out, leaving me with the a subtract b. Now, anytime there's a negative, you write the negative down. You always want to factor that negative out. So if I factor that negative out, then I also have an a subtract b. Now looking at my two groups, you can see I have an a subtract b that's the same. So the a subtract b is going to factor out, and I'm left with an x squared. And then this is where a lot of students miss. There's a 1 there, 1 placeholder. So you have an x squared subtract 1 that's left. So check to see if you did that right. Now this is a difference of 2 squares. So you're going to have the x plus 1 and the x subtract 1, and then that's going to be your final answer. So here were my two answers on example 9a and b. 10 is a reminder on how to factor. I usually like to put this x chart. In the top goes a times c, and in the bottom is the middle term. So a is 1, so 1 times negative 14 is negative 14, and we need to add to get 5. I know 7 times 2 is 14. To determine which one is negative, to give me that negative 14, I want the smaller number negative so that when I add them, I get a positive 5. So now I'm ready to factor. It's x times x is x squared. You have a 7 and a negative 2, so plus 7 and minus 2, and you've just factored. Looking at b, you notice a is no longer 1, it's 2. There's many ways to factor this. Split the middle. The latest and the newest craze is the a times c method. 2 times negative 15 is negative 30. And then you have negative 7 is what you're adding to get. So you want to think of the two numbers. 30 has a lot of factors. So you'll go through and you'll try to think of all the different factors, but you want to get negative 7. So I am thinking 10 times 3. And we want the 10 to be negative so that when you add these, you get negative 7. But when you multiply them, you get negative 30. So now here's the new method. For first times first, you actually use a 2x and a 2x. And the reason why you're doing that is you're really factoring out a half to make that possible. All right, and then you have the subtract 10 and the plus 3. Then what you do is you just simplify these by taking the 1/2 and multiplying it back through. What I like to do is divide both of these by 2, and then nothing is going to simplify in this second one. So this is going to give me x subtract 5 and 2x plus 3. If you're unsure, you should always check 2x times x is 2x squared, 3x minus 10x is negative 7x, and last times last is negative 15. I started this problem by factoring out the GCF of 2, leaving me this, and then I went over here and I did the AC method. So a times c was 12 times negative 15, which is negative 180. And then I have 11 in the middle. My two numbers are 20 and negative 9. So now I'm going to rewrite this as 12x times 12x. And the only reason I can do that is because I factored out a 1/12. And I haven't forgotten about this 2. I'll write that 2 at the end. And then I have a plus 20y and a subtract 9y. Then I'll take the 1/12 and I'll multiply it through. So here I can divide by 4. Let's put that in red, 4. And here I can divide by 3. And that's my 1/12. 4 goes into 12 3 times. So that's 3x plus 3y, 5y. And 3 goes into there, 4x subtract 3y. I still have that 2, so I'll bring that 2 down. And now that's my final answer. I can check it. 3x times 4x is my 12x squared. Negative 9xy plus 20xy is 11xy. And 5y times negative 3y is negative 15y. This is a difference of squares. X squared times x squared and 4 times 4. So x squared times x squared is x to the 4th, and 4 times 4 is 16. So you're going to do a plus b and a minus b. And then this is a difference of squares, so we can factor it as x plus 2, x minus 2. If they want real numbers, then you will leave the x squared plus 4. However, if you want to get fancy, you can factor that as a sum of squares, which will be x plus 2i and x subtract 2i. When it's a sum of squares, you always get imaginary. So there's your plus, and then 2 times 2 is 4, and x times x is x squared. And then you would have the x plus 2 and the x subtract 2. So it just depends. Is the question asking for reals, or is the question asking for imaginaries? So let me highlight that final answer. All right, let's look at example 12a. You want to put in the Cornell that you have u is going to be equal to the square root of x. This looks quadratic, just like usually you have a square and then you have to the first power. This is the same thing, except for you have x to the first and then x to the half. Square root is x to the half. So if u is equal to the square root of x, then u squared, if you take root x times root x, then you get simply x. So we're going to replace these with u. So in place of x, we're going to put in u squared. And in place of root x, we're going to put in u plus 6. Now you have a really simple problem to factor. I'm just going to do guess and check. U times u is u squared. I need to multiply to get 6. So I could do 6 times 1, or I could guess 2 times 3. I'm going to guess 2 times 3 because when I check the outside insides, 3u and 2u is 5u. And then 2 times 3 is 6. All right, so now what I'm going to do is just take the u and substitute in what u equals. So my final factored answer is going to be the square root of x plus 2 and the square root of x plus 3. Problem, yay! So, and my son keeps coming in and asking for dinner. Dinner is in 10 minutes after this problem. So looking at B, yeah, they want to eat, so I've got to hurry. So you see how you have x to the 6th and x to the 3rd? See how it goes to the 6th power and then it's cut in half to the 3rd power? That means that it's quadratic in nature. So what you can do is whatever this term is here is what you let u equal. So u is equal to x cubed. That means that if you were to do u squared, if you take x cubed and square it, it's x to the 6th. So we're going to replace the x to the 6th with u squared. So now you have 2u squared, subtract 15u, subtract 8. We're going to go ahead and factor this. We'll do AC method. 2 times negative 8 is negative 16 with negative 15 in the middle. So A times C, and then negative 15. I'm thinking it's 16 times 1. The 16 is going to be negative to give me the negative 15. Now, shortcut factor, I'm not going to factor out the half. I'm just going to say 2u times 2u. And I've factored out a half. And I have negative 16 and positive 1. One or both of these will always, always, always reduce. So the first one, I can multiply the half through and get 2. Divide those both by 2. Nothing's going to reduce in this second one. So now u subtract 8 times 2u plus 1. Take the u and substitute it back with the x cubed and you'll be done. So now I have x cubed subtract 8. Ooh, I lied. We're not going to be done. And 2 times x cubed plus 1. Do you guys notice that this is a difference of cubes? So see if you can factor the difference of cubes for the final answer, SOAP. Answer, and that is it. Yay! I can go make dinner so my children don't starve. All right, have a great, fabulous day, and I will see you guys